Hi everyone, in this video I will be demonstrating how Veritas Alta Enterprise Resiliency provides high availability for SAP in the public cloud. Let's first do a quick overview of the main SAP components. SAP is comprised of three tiers: a presentation tier, an application tier, and a database tier. The presentation tier is a graphical user interface that interacts with the end user. The application tier has two components: the ABAP SAP Central Services, composed of two parts: the message server, which handles the distribution of the load and the communication between the application server, and the in-queue server, which controls the locking mechanism. There is also the application server that handles the actual data processing of the request. The database tier is an in-memory database for storing the data. Now that we know the basic components, let's look into how to make SAP highly available. Only the application tier and database tier would need to be made resilient from single points of failure. For high availability, a minimum of 2 nodes is required with the same set of SAP components running on the other node in either active or passive mode. For the central services, an in-queue replication server is required to keep a replicated copy of the lock table. In addition, shared storage is required for the central services and the in-queue replication server. There is an additional application server that is deployed and active on the other node. As for the database, there is one primary database and a standby database to take over in case of failure. Transaction logs are shipped constantly to the standby database to update the data in the other node. This is referred to as log shipping. SAP does not have a clustering mechanism to do an automated failover of its components. This is where Veritas Alta Enterprise Resiliency, comprised of both application and storage resiliency, is most advantageous. For the application tier, both the application cluster services and shared storage capability is needed, and for the database tier, only the application resiliency component is employed. Let's now see a demo of Veritas Alta Enterprise Resiliency providing high availability for SAP in the public cloud. From the AWS console, there is a VPC created in North Virginia region which has 3 availability zones: route tables and DNS. There are 2 EC2 instances with EBS volumes in different availability zones for the application tier. And 2 EC2 instances with EBS volumes created in different availability zones for the database tier. For application tier, both components of Alta Enterprise Resiliency are installed on each of the nodes to form a 2-node cluster. For the database, only the Alta Application Resiliency component is installed to form another 2-node cluster. A coordination point server is deployed on an EC2 instance in a different availability zone to maintain data integrity for each of the clusters for split-brain scenarios. The centralized management console, also known as VM, is deployed on another EC2 instance to manage storage and high availability of the resources for the cluster. In DNS, there are entries for each of the EC2 instances in this deployment, and entries that allows for the high availability of SAP. These additional entries hold the virtual IP addresses associated with the primary network interface of each node that is active for the SAP resource. Now let's look into how Veritas Alta Enterprise Resiliency makes SAP running in this environment highly available using VM, the centralized management console. Under the Data Center in the Server tab, we can see that 4 EC2 instances have been registered. There are 2 instances that form the application cluster and the 2 instances that form the database cluster. Expanding the system resources of one of the nodes in the application cluster, a disk group is created enabled for flexible storage sharing. This disk group is comprised of the EBS volumes in each of the EC2 instances in the application cluster. From the disk groups, volumes and cluster file systems are created, mounted, and are accessible by both the nodes in the application cluster. In the availability view, we can see the 2 clusters, the database cluster and application cluster, and the EC2 instances that are part of each cluster. The SAP HANA database is first installed in each of the nodes on the database tier, and one node is configured as primary and the other node as a standby. To place SAP HANA database under control of the Veritas Alta Enterprise Resiliency, in the Availability tab, 2 service scripts have been created to define how the resources within the cluster are to be started and stopped, as well as how the database automatically fails over when the primary database becomes unavailable. Veritas Alta Enterprise Resiliency has specialized agents for SAP to simplify the creation of the service group. Under this service group, you can see a specialized agent for the SAP database. Attributes such as environment, profiles, and parameters related to the database are set for the resources within this service group. In Volume View, the database is active in both nodes where one is a primary database and the other is in standby. As for the SAP Takeover Service Group, the resources are in failover mode such that if the primary database indicated by the blue box becomes unavailable, it will trigger the failover mechanism that would promote the standby database to primary and modify the virtual IP in DNS to the virtual IP of the standby database. The resources in this service group involves the agents for IP, network interface, and DNS. After the database is configured, the components of the application tier is then installed on each of the nodes on the flexible shared storage previously created. Let's review the service groups within the application tier. Looking at the Data SG service group, the volumes for SAP are active and mounted on both nodes as indicated by the blue boxes underneath each node name. The parallel mounts allows for fast failover to passive node when active node fails. For the SAP Central Services service group, it is in failover mode, such that the main resources are only active on one of the nodes indicated by the blue boxes and passive on the other node as indicated by the gray boxes. Similar to the database cluster, there are specialized agents for the SAP application tier as shown here when we expand the service group and look at the resource attributes within the service group. From the service group status of the application cluster view, we can see how the rest of the SAP components is being managed within Veritas Alta Enterprise Resiliency. One can see that the central services is active on Node 2 and passive on Node 1, and the in-queue replication server is active in Node 1 and passive in Node 2. As part of the SAP co-location rules, the central services and the in-queue replication server would need to be run on opposite nodes. Veritas Alta Enterprise Resiliency provides pre- and post-online triggers that would enforce this rule. For the application servers, the primary application server is running only on one node, and the additional application server is running on the other node. Veritas Alta Enterprise Resiliency's main role for the application server is to start and stop them on their respective nodes. Now that we understand how Veritas Alta Enterprise Resiliency manages SAP components for high availability, let's simulate a failure first on the database cluster and then on the application cluster. Let's first review the current state of the SAP database components in Viam, the AWS console, and the SAP HDB Studio application. As shown in Viam, from the database cluster resources group, the primary database is on SAP HANA 1 as indicated by the SAP Takeover Service Group, and in the SAP HDB Studio application, the mode is set to primary for SAP HANA 1 and sync for the standby database node SAP HANA 2, indicating that all data has been replicated and in sync with the primary database node. From the AWS console, we can also see that the DNS entry for the database holds the secondary IP address for the primary database node SAP HANA 1. Also shown for the Microsoft Management Console, which has the plugin for the SAP Central Services and the in-queue replication server, the SAP application cluster is up and running. Let's now shut down the primary database node SAP HANA 1. From Viam, you can see that the service groups in the database cluster have faulted and are in an unknown state on SAP HANA 1 as indicated by the yellow question marks, and the service groups are now coming up on SAP HANA 2 and a takeover is occurring. After all the services has been started in SAP HANA 2, we can see from HDB Studio that SAP HANA 2 is now the primary database, and the DNS entries has been updated to the secondary IP addresses of SAP HANA 2. This automatic failover is being orchestrated by Veritas Alta Enterprise Resiliency. We can also observe that the application cluster was not disrupted by the shutdown of the primary database, and it continues to run as shown in the Microsoft Management Console. Now let's see how Veritas Alta Enterprise Resiliency provides high availability for the SAP application cluster. But first, let's review the state of the SAP components within the application cluster. For the application cluster, the data volumes are mounted on both nodes for fast failover. The central services are running on S/4HANA 1 and passive on the other node. The in-queue replication server is running on S/4HANA 2 and passive on the other node. The primary application server is running on S/4HANA 1 and an additional application server is running S/4HANA 2. From the AWS console, the DNS entries reflects the secondary IP addresses of the nodes that the central services and the in-queue replication service are running on. We can also see from the Microsoft Management Console with the SAP plugin to observe the running state of the SAP Central Services and the in-queue replication server as indicated by the green running status. Note that the logs from the Central Services is replicated to the in-queue replication server and both contain the same log information. From the AWS console, let's now shut down S/4HANA 1, which is one of the nodes in the application cluster. From the service group status and volume, the service groups running on S/4HANA-1 turns into an unknown state as indicated by the yellow question marks, and the central services are coming up on S/4HANA-2. Also from the management console, you can observe that the node S/4HANA-1 and the central services are down, and that there are no in-queue locks. Since the data volumes are mounted in both nodes, defined in the Data SG service group, this service will not need to be brought up. This concurrent mount eliminates the storage operations required to start the SAP central services and provides the fast failover of service onto node S/4HANA-2. Since the application server and the in-queue replication server is already running in S/4HANA-2, those services would not need to be brought online. Now that all the services are running, from the Microsoft Management Console, you can see that after a refresh of the in-queue logs on the central services, that the logs has been recreated based on the logs from the in-queue replication server. And from the AWS console, we can see that the IP address of S/4HANA-2 is now the virtual IP for the DNS entry for the central services. This automatic failover of SAP components is being orchestrated by the Veritas Alta Enterprise Resiliency. As shown from this demo, Veritas Alta Enterprise Resiliency adds significant value for SAP by providing high availability and resiliency in the public cloud. Thank you for watching.